The purpose of this project is to make a demonstration in the mechanical and structural field about the fall of the Twin Towers in 2001. The main object of the project is to make an analysis that includes the total inertia of the building, such as the floor that was hit by an airplane, the critical load, the amount of load, and the reduced E for the headed steel. In the figure 1, we can appreciate the blueprints of the floor that was hit by the airplane. The floor hit was the 80th floor. The distribution of the columns at this floor were 59 columns at his perimeter per side, leading to a total of 236 perimeter columns. In the figure number 2, we can appreciate the core of the floor that has a distribution of 48 columns in a rectangle located at the center of the floor. This rectangle has 27 mirrors on one side and the other of 41 mirrors. All columns have the same measures and are evenly distributed to keep symmetry. We calculate the total moment of inertia x-axis of the whole floor using the theorem of parallel axes. To calculate this inertia, first we need to calculate the centroid of one of the columns, since all columns have the same measures. Knowing this now, we are able to calculate the inertia. We proceed calculating the inertia with the help of a table in Excel to have a better control of the calculation and the proper use of decimals in order to have a most accurate result. As we can see at the blueprints, the distribution of the columns at the 80th floor, the next step was to multiply the inertia of the column calculated by the total amount of the columns of that floor. And we can say that we calculate the total moment of inertia x-axis of the floor. Moreover, we calculate the inertia of y-axis. Since the columns have the shape of a square at the base, at the moment of inertia is the same as the both axes. To make these calculations, we made two assumptions for the length of columns. One assumption is the length of the regular floors that was 3.8 meters, and the other one is the length of the service floor that was 3.08 meters. Saying this, we need to make two different calculations for the critical loads, one for the regular floors and the other for the service ones. Again, the numbers were made with the help of a table Excel to be more accurate.
For the damage moment of inertia, the only thing that we did was to take out all the columns that were hit by the airplane and the ones that fell down by the impact, and calculate again the moment of inertia, but this time multiplying by the amount of columns that remain intact after the impact. And that should be the new moment of inertia. We found that the heat at the inside of the building reaches around the 800 Celsius degrees. Then we found a table that shows the behavior of the modulus of elasticity when it's heated. So we use this table to make our numbers for the next step. For this step, we need to do the same numbers that we do at the point number 5. However, we are going to use the new E of steel when the steel is at 800 degrees. The numbers were made again with the table in Excel that we used before, only changing the E. We tried to find how much the floor weighs, but we only find out how much the entire building weighs. So we estimate the weights of each floor by dividing the weight of the building by the total number of floors, and with this we made a calculus of the amount of load and the 88th floor loaded. Then we compared the load that each floor should loaded with all the load that the 80th floor loaded after the impact and the burn steel. After seeing all the calculations that we made for the project, we conclude that by itself the crash of the airplane didn't have a significant impact in the fall of the building. However, the fuel of the airplane was the main factor of the failure of the structural system. The structural steel melting and the speed in which it did were detrimental, so that the structure was losing all its lifting capacity, so that finally a domino effect was created. In all the building that did that, all the building collapsed. Our numbers show that the load of the floor was overcome, and that creates the failure of the structural systems.